Okay, 3.7a, variations and applications. Are you ready for a big change with things that are probably going to be a little bit simpler than we've done in the past? We're going to do direct variation, inverse variation, and end with combined variation. And direct variation is basically multiply, inverse is divide. Okay, so if you can remember that. Whenever a situation produces pairs of numbers in which the ratio is constant, we say that there is a direct variation. So, if we look at the formula for direct variation, it looks like this. F of x equals kx, or you could write it as y equals kx. And what you do with these is your first step is to find k, and then you write your equation out. That's usually what they want you to do, is find k, write the equation out, and then solve it. So we'll just go into example 1. Find the variation constant and an equation. Variation constant is this letter right there. And an equation of variation in which y varies directly as x. Alright, whenever they say y varies directly as x, they're saying this, y equals kx. So if they use the word directly, that means that you are going to be doing multiplication. Now if they use inverse, which they will later on, that will mean divide. So right now we're just dealing with direct, so it's going to be multiplying. So in which y varies directly as x, and y equals 32 and x equals 2. So I said first of all we're going to find the k. So we're going to take this equation, y equals kx, varies directly, and we're going to find k first. Well, what do they tell us about y? Because in order to solve this, you can't have 3 variables, you can only have 1 variable. So k equals 16. So that's the first step. So the equation of variation is y with our 16 in there times x. Okay, that's all you do. So you find k. So you're finding the variation constant, and then you're finding the equation, which means you're just putting k in once you find it into that equation, and you're done. Alright, so let's look at some more story problem-ish problems here with example 2 dealing with the melting snow, which it's going to be a while for that to happen. The number of centimeters, W, of water produced from melting snow varies directly as S. Alright, so when it says that, it tells you how to write this equation. W varies directly to S. Okay, so there you got your formula. And first thing we're going to do is find k. So they should give us a number for W and a number for S so that we can find k. Alright. Meteorologists have found that 150 centimeters of snow will melt. What does W stand for? Water produced from melting snow. And it says that 150 centimeters of snow will melt to 16.8 centimeters of water. So the water is going to be the the water is going to be the 16.8, and the melting snow is going to be 150. Okay, you go ahead and divide things out and you get 0.112 for k. So then your formula, or to how many centimeters of water will 200 centimeters of snow melt? So we've got our formula. Our formula is W equals 0.112 S. Okay, there's our formula that we derive from this by finding the constant. Now they're going to ask us a question using that formula. How many centimeters of water will 200 centimeters of snow melt to? Okay, so that's what we're looking for. So all we're going to do then is take the information that they gave us, water, that's what we're looking for, and they're saying, okay, if we have 150 centimeters of snow, how much water will that give us using that formula? And that gives us 22 0.4 centimeters, not inches, of water. All right, so what happens is we got a general formula here. Right here is our general formula. That means we can put any depth of snow here, and it will tell us how much water we get out of it. Okay, so this coming up with this formula gives us a real nice thing to use, because now we can just take any depth of snow, put it in here, multiply it by 0.112, and it'll tell us how much water we have. So if you go outside and you say, oh, wow, there's 6 inches of snow, I wonder how much water that will melt to. Well, take 6 times that, and that will give you how much water you're going to get. So what you're doing here, just to kind of give you the steps here, you're writing the formula, the direct variation formula. They tell you it's direct variation because they say it varies directly. Varies directly is basically the equal sign multiply. So water varies directly as K times the depth of the snow. You find K, you replace K with the number you get, and now you have this general formula, which means you can put any number here and it'll spit out a number here. But they tell you what number to put in here. In fact, this one it said 150 centimeters of snow will give us how much water. So they're specific on how much snow there is. But this formula works for any depth. But they just want this particular depth, 150 centimeters, and want to know how much water you get. And that ends up being 150 centimeters is, 3.5 feet of snow. And it gives you about 10 inches of water. So if you're translating it back into the English version, that's kind of what you've got there. All right, so let's go to inverse variation. I told you inverse variation is not like the multiplication. It's going to be division. It's going to be y equals k over x. Okay, so that's what this is going to look like. So y equals kx is direct variation. This is inverse. It's done the exact same way. It's just you're dividing here instead of multiplying. You're finding k, plugging it in to get the general form of the equation, and then answering the question that they give you in the example. So let's do a couple of those. So example 3 says find the variation constant, so that's the k, and an equation of variation in which y varies, inversely as x. Okay, so first thing we're going to do is find k. So they have to give us an x and a y in order for us to find k, and they do. 16 equals k over 0.3. So therefore we find k is 16 times 0.3, and that ends up giving us 4.8. So then our equation looks like this over x. Is that all they wanted? Find the variation constant and an equation. That's all they wanted. Okay, 4.8 over x. All right, so example 4, they're going to give us an actual problem using this inverse variation here. Has to do with construction. The time required to do a job varies inversely as the number of people. So time varies inversely as the number of people. Okay, first write my equation. If it takes 72 hours for 9 people to frame a house, how long will it take 12 people to complete the job? So we use the first numbers to get our k there. So we find out that our k is 72 times 9, 648. Now we write our equation with k in there. And there's our general equation. Now we're going to find out specifically what they're interested in. How long will it take 12 people to complete the same job? So now what we're going to do is put a 12 in there. 648 over 12. And that gives me 54. So it'll take 54 hours for 12 people to do that job. So let's say that you are actually doing construction here, and let's say that one of your guys is sick that day and you don't have 12 guys. So you're going to have to change that number to 11, and then you can find out how much more time it's going to take. And then it gives you an idea of what your payroll is going to be, because you're paying these guys so much money per hour, and it's going to take them 54 hours total. So you're going to pay 12 guys for 54 hours work, and that gives you an idea how much it's going to cost. But one's sick. So now you only have 11 guys, so how long is it going to take them now? So 648 divided by 11. Or let's say 6 of them quit one day, 648 divided by 6. So it gives you an idea of how many hours it's going to take to frame up this house. So it's kind of a nice little idea to use here. All right, I am going to stop this video. We just have combined variation to go, but I'm just going to stop it at this point, and the next one will be combined variation.